to Science Fantastic with Professor Michio Kaku. Every week on Science Fantastic, we profile some of the most amazing developments in science that touches our lives. And once again, we have with us Dr. Ken Croswell, our favorite astronomer from Berkeley, author of a number of great books, including Alchemy of the Heavens. And today, we're going to talk about something that's hitting the news briefly, and that is the sun. That's right. We take it for granted. The sun rises in the morning, sets in the evening. It's dependable. It's always there. But recently, the European Space Agency and NASA sent a new probe around the sun, the solar orbiter, to answer some of the secrets of the sun. Because the sun is incredibly crucial for our existence. It controls the weather. And when the sun has a temper tantrum, watch out. Solar flares can easily disrupt communications on the planet Earth. And then we have to worry about sunspot cycles and what happens with our astronauts if they're hit by a coronal mass discharge from the sun. So all these things we're going to talk to Dr. Ken Croswell as we talk about something that shines in our life every day, but we don't think about it, and that is our sun. Well, with us once again today, we have with us Berkeley astronomer Ken Croswell talking to us today about the sun, something that we take for granted, and yet it controls our very life. The weather, crops, agriculture, sunlight, energy that drives our Earth, all of it depends upon the sun. And recently, the European Space Agency and NASA sent a probe around the sun to answer some of the mysteries. And so not only that, we'll also talk about what happens when stars go berserk. What happens when they explode? Did you know that Betelgeuse, a gigantic star, a red star in the heavens, is unstable? Astronomers are on alert. We don't know if it's going to explode. It could explode tomorrow. It could explode 1,000 years from now. All we know is Betelgeuse, a giant red star, is unstable, and astronomers are on the alert because if that star does in fact blow up, it could easily outshine the moon. It could be visible in daytime. When was the last time you saw a star visible in daytime other than the sun? Well, we're talking about Betelgeuse, not the movie. Betelgeuse, the star, which apparently is unstable. So we'll talk about what happens when stars explode. We'll talk about neutron stars and black holes. So anyway, once again, with us today is Dr. Ken Croswell, astronomer at Berkeley. So Ken, tell us a little bit about the solar orbiter, which was just recently launched, and it'll take a few years before it goes into a stable orbit around the sun.
Yes, good to be here, Michio. The sun, as you say, is very important to our lives. It's the main ingredient in our climate. Without the sun, we wouldn't be here. And the solar orbiter was launched on February 9th, Eastern Time, and it will take a couple years to get into its prime orbit, but it's going to give us a view above and below the plane of our solar system, of the sun, and study the north and south poles of the sun. You may recall when the Juno spacecraft went into orbit around Jupiter, we got our first good views of the poles of Jupiter, and the poles of Jupiter looked very different from the rest of Jupiter. Perhaps we'll see some surprising things when we examine the poles of the sun, because other spacecraft have stayed mostly in the plane of the solar system, and this spacecraft, the solar orbiter, will instead be rising above and below the plane of the planet. So it's going to be interesting to see what the solar orbiter sees, but we'll have to wait a couple years before it gets into its prime orbit.
Okay, well, let's back up a bit and go through a very elementary introduction to the sun, which is the nearest star to the planet Earth. First of all, let's start off with the question that every child wants to know the answer to, and that is, what makes the sun shine?
Well, the sun, like all other stars, shines for a very simple reason, because it's really, really hot. Okay, you don't have to say one word about nuclear reactions. We'll talk about them in just a moment. But anything that's really hot is going to emit light, visible light. So, for example, on an electric stove, electric stove, you turn it on, it gets hot, it starts to glow. Likewise, the sun, whose surface temperature is about 10,000 degrees Fahrenheit, is so hot that it emits visible light. Now, you then ask the question, well, how did the sun get so hot? And the answer is, long, long ago, a cloud in space made of gas and dust started to collapse under the force of gravity. And as you, a physicist, should know, anytime you compress a gas, that gas gets hotter and hotter. And so at some point, the sun got so hot that it began to emit visible light. But it was not yet engaged in nuclear reactions. Those happened later. As the sun collapsed further and further, though, its core got so hot that nuclear reactions began at the core. The main nuclear reaction that the sun engages in to sustain its heat is the conversion of hydrogen, the lightest and most common element in the universe, into helium, which is the second lightest and second most abundant element in the universe. And so the sun keeps itself hot because of those nuclear reactions. And this has been going on for the last 4.5 billion years, which just shows you, number one, that nuclear reactions are a really good source of energy, and number two, the sun has a lot of fuel. The sun is a very big thing. It is the biggest thing in our solar system. You could put the Earth and the moon and all the space in between the Earth and the moon inside the sun and still have plenty of space left over. That's how big the sun is. This is the biggest and most massive object in our solar system, and all the planets of our solar system, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto, yes, it is a planet, and Earth, they all go around the sun under the influence of its gravity. Furthermore, the sun is 1,000 times more massive than the largest planet in the solar system, which is Jupiter. So the sun is a big deal in the solar system.
Now, here's where Einstein comes into the picture. Even school children know the equation E equals mc squared. So break that down for us. What is E, what is m, and what is c squared?
Well, E is energy, m is mass, and c is the speed of light. And what Einstein's equation says is that if you take a mass m, multiply it by the speed of light squared, which is a very big number, that's how much energy you get out if you convert the mass into energy. And that's exactly what the sun is doing every second. It is converting hydrogen into helium, and in that process, a tiny amount of mass is converted into energy.
Okay, Ken, we have to take a short commercial break. Science Fantastic with Professor Michio Kaku. Once again with us today is our favorite astronomer, Dr. Ken Croswell of Berkeley, author of a number of great books, including Alchemy of the Heavens. And today we're talking about the most familiar star in the universe, our sun. Something we take for granted, and yet once in a while it has a temper tantrum, throws off gigantic solar flares which could endanger the planet Earth, and one day it will die. We came from the sun. The earth came from the sun in some sense, but one day we will go back into the sun. The Bible says, from dust to dust, ashes to ashes. Physicists say, from stardust we came, and stardust we will return. Well, Ken, we were talking about the sun. The sun is 4.5 or so billion years old. But how do we know that? How do we know how old the sun is? And once we figure that out, how do we know when the sun will eventually die?
Well, we are able to radioactively date materials in the solar system. So we can compare the composition of, for example, asteroids. The asteroids fall to Earth in the form of meteorites. We can take those meteorites into the laboratory, and we can compare ratios of different elements, for example, uranium decaying into thorium. And in this way, we've established that the solar system, and thus the sun, is 4.5 billion years old. Now, as to what will happen in the future, well, we are able to calculate that certain changes are going to occur in the sun's future. As I mentioned earlier, the sun is converting its hydrogen into helium at its center, but sooner or later it is going to run out of helium at its center, at which point it will start burning hydrogen in a shell around the center. And at that point it will start to expand and cool, because an expanding gas cools, and it will eventually become a red giant star. Okay, now this is a star that's about 100 times brighter than the current sun.
Okay, now Ken, you said that the sun will expand to become a red giant as it uses up its hydrogen, but what happens to the Earth when the sun starts to expand like that?
Well, we don't know, to be honest. We are certain that Mercury, which is the closest planet to the sun, will get swallowed up by the sun. So you don't want to be living on Mercury. Venus probably will get swallowed up. Mars will probably survive. The Earth's fate is not clear. So I don't know what's going to happen to the Earth. It may get swallowed up by the sun, or it may survive. Either way, though, because the sun will be so much brighter then, the Earth will be incredibly hot. And so you would probably want to move out to the orbit of Saturn. Saturn is about 10 times farther from the sun than the Earth is, and since the sun at that time will be emitting about 100 times more light than it is right now, well, 10 is the square root of 100, therefore you want to be 10 times farther out in the solar system than you are now if the sun is 100 times brighter. So I think in the very far future, we're going to need to move out, or we could possibly move the Earth away from the sun. Who knows? Who knows what we'll be able to do many billions of years from now, because these things are not going to happen anytime soon.
Well, every religion has some kind of folklore about Armageddon or Doomsday or the end of the world. And you're saying that, well, if we can't move the sun, if we can't move the Earth, then perhaps the sun will eat up the Earth when the sun expands. But eventually, you said, it's going to eventually become a white dwarf. Now, as I understand, a white dwarf is so dense, it's so small, that it's roughly the size of the Earth, but it weighs as much as the sun. So tell us a little bit about the white dwarf star, which is the end product of a lot of this fusion going on for billions of years.
Yes, white dwarf stars are quite common. About 5 or 6% of all stars in the Milky Way galaxy are white dwarfs. In fact, the nearest one is just 8.6 light years away in orbit around the bright star Sirius, which is actually visible in the night sky tonight. So white dwarfs are very dense stars. They typically have maybe 60% the mass of the sun, but as you say, they're only about the diameter of the Earth. And so a spoonful of a white dwarf would weigh several tons. That's how dense they are. Furthermore, white dwarfs are the stars that are fading from view because they're getting cooler and cooler as they radiate their meager amount of light into space. So over time, they actually change color. So they start off hot and blue, and then they become white, and then yellow, orange, and red. So despite their name, they can be in various colors.
So eventually now, billions and billions of years into the future, when the sun becomes a white dwarf and starts to use up whatever energy is left, won't it simply become a dark piece of nuclear waste? Is that the ultimate future of the Earth, the solar system, and the sun itself, to become a drifting mass of black nuclear waste?
Yes, and we have a term for such stars, black dwarfs. However, the universe is sufficiently young that no star has yet become a black dwarf, because it takes billions and billions of years for a white dwarf to get sufficiently cool that it turns black. So if you come back in 100 billion years, you'll find lots of black dwarfs in the universe, and our sun, unfortunately, is going to be one of them.
Okay, now let's talk about an alternate history. Let's talk about Betelgeuse, a giant red star in the heavens. It's apparently unstable, and astronomers are on the alert now. Here is a giant star, unstable, and unlike our sun, apparently is big enough, massive enough to explode. So explain to us what is happening with Betelgeuse.
Well, Betelgeuse is, first of all, a very beautiful star, and it, too, is visible in the sky tonight. Just look south around 7 p.m., and you'll see the constellation Orion. All the bright stars in Orion are blue, except for Betelgeuse. Betelgeuse is red. It's not a red giant. It's actually a red supergiant, so a very different type of star from what the sun will someday become. And our standard theory is that red supergiants ultimately explode as supernovae. Now, I should warn you that there is lately been some questioning of this standard theory. And in fact, I just recently did an article for the Proceedings of the National Academy of Sciences in which I presented some evidence and quoted some astronomers who are finding that not all red supergiants actually explode as supernovae, that instead some of them instead collapse or implode and become black holes without going supernova. And we don't know which category Betelgeuse is in. Now, in recent months, Betelgeuse has been acting strangely in that it's considerably fainter than usual. Normally, Betelgeuse is either the brightest or the second brightest star in the constellation Orion. But lately, it's been about as faint as Bellatrix, which is another star in Orion. And now, I don't think for 1 second this means that Betelgeuse is going to explode anytime soon, but the star clearly is unstable. Understand that red supergiants are very big stars, okay? Unlike red giants are bigger than the sun, but red supergiants are even bigger than red giants. A typical red giant is about 100 times brighter than the sun. A typical red supergiant, like Betelgeuse or like Antares in the constellation Scorpius, these stars are 10,000 times brighter than the sun. So these are much bigger and brighter stars than ordinary red giants. And they have typically a very different fate, which is usually they explode, although in some cases we've got evidence that they don't explode, but instead they implode and become black holes.
Okay, now assume for the moment that Betelgeuse does explode. I understand that there's a lot of speculation as to what it's going to look like. Some people say that it'll be visible in daytime. I mean, when was the last time you saw a star visible in daytime? A star that would be comparable to the moon at night. But what are your thoughts?
Well, when Betelgeuse explodes, it's going to be far brighter than the planet Venus. And Venus, if you know exactly where to look, actually is visible during daytime. Okay, so Betelgeuse is going to be a lot brighter than that. It will be visible during the daytime when it explodes. It's going to be way brighter than Venus. Probably not quite as bright as the moon, but well, every red supergiant explodes in a different way. So we'll have to see.
Okay, well, let's take another short commercial break. Back to Science Fantastic with Professor Michio Kaku. Today we're talking about our sun. It sounds such a familiar concept. We wake up in the morning, the sun's there, the sun sets. It's predictable. But recently, the European Space Agency and NASA sent a solar probe, a solar orbiter around the sun. It'll take a few years to get into its proper orbit, and it'll try to answer some of the questions about our sun. Well, we talked about big stars like Betelgeuse, much bigger than our sun, and they may have a different life story. They're so big, they may actually explode into what is called a supernova. So Ken, tell us a little bit about supernovas. How dangerous are they? And what about like the Crab Nebula, which apparently is a remnant of an ancient supernova? And how dangerous is Betelgeuse, which apparently is unstable at the present time?
Betelgeuse will not harm us because it's many hundreds of light years from Earth. So if it were to explode tonight, which it probably is not, it would not hurt the Earth whatsoever. So we're no danger of Betelgeuse. Furthermore, the stars that explode are really quite rare. As I stated in my book, The Lives of Stars, the most massive stars are quite uncommon. And in fact, even stars like the sun, which don't explode, the sun is not even an average star. The sun is actually much brighter than the typical star in the Milky Way galaxy. 95% of all stars in the Milky Way are stars that emit less light than the sun does. So the vast majority of stars never explode. And so we really don't have to worry about supernova explosion destroying the Earth, because it's so rare that these events happen, and they happen so far away. The last time we saw a supernova in our galaxy was actually in the year 1604. That's more than 400 years ago. It would be very nice to see one again at sometime in our lifetime, but there's no guarantee of that. But we're really in no danger from a supernova explosion.
Now, some people say that our sun is like an oven. It cooks hydrogen to create helium, but not much more than that. A few light elements, perhaps. The sun is not hot enough to cook the elements of our body. And then the question is, does that mean that our sun, therefore, is not our true mother? That the elements in our hands, our body, our hearts, our brains, the elements of the periodic chart were not forged in the sun at all, because the sun is not hot enough to forge these higher elements. And some people think, well, where did the elements of our body really come from? A supernova. So in other words, is it true, therefore, that we are not only made out of stardust, we're made out of stardust of an exploding star, maybe even a second or third generation exploding star, that yes, we are made out of stardust, but our true mother was basically a star which blew up billions of years even before our sun was created. What are your thoughts?
Well, actually, hundreds of millions of stars have contributed to the life-giving elements that make up our bodies and our planet. Now, the sun later in life will create heavier elements such as carbon and nitrogen, but as you say, it's not yet died, therefore it hasn't done these things. So the heavy elements on Earth that give us life, like oxygen and iron, they were created in both red giant stars, which do not explode, and also in more massive stars that did explode.
So it's kind of humbling, right? Realizing that we are made out of stardust of ancient stars, millions of them perhaps, which exploded billions of years ago. Welcome back to Science Fantastic with Professor Michio Kaku. Our special guest today is Berkeley astronomer Dr. Ken Croswell, author of a number of great books, including Alchemy of the Heavens. Well, some people may say, what about me? What about me today? How's the sun going to affect everyday life? Well, when you go back in history, you realize that periodically the sun does emit solar flares. Once in a while, they are so big, they actually can interfere with activities on the planet Earth. Not just endangering astronauts, not just giving us static on radio, but actually with the potential to cause blackouts, to wipe out power stations, to create mass panic. In 1859, we had the famous Carrington event, where the sun blew off this tremendous solar flare, which interfered with telegraph wires, because that's all we had back in 1859. And some physicists say that if once again we have a coronal mass discharge, it will cause blackouts over much of the Earth and could even paralyze the world economy. Well, Ken, what are your thoughts about what happens with the darker side of the sun? And that is what happens when the sun blows its cool, sends off huge solar flares, which can affect not just our satellites, not just our astronauts, but actually cause blackouts in power stations and cause maybe enormous $1 trillion of damage.
Yes, it's something that has happened in the past in terms of these big solar events. As you point out, the 1859 event was tremendous. Back then, of course, we didn't have the enormous network of electrical grids and computer systems and all of that. But if a similar event were to happen today, it would almost certainly cause enormous damage, and I wouldn't be surprised if it would cost trillions of dollars. So it makes a lot of sense to harden our electrical system and our computer systems against such a catastrophe, because it is going to happen sooner or later. I mean, the last one, as you point out, was 1859, but the next one, it could be next year, it could be 100 years from now, but these things do happen, and we need to protect ourselves.
Now, I once read an article which I thought was rather scary, and that is sunspots. We see sunspots on the surface of the sun, which are apparently storms, magnetic storms on the sun. But actually, these sunspots are like rifles that shoot out masses, coronal mass discharges, and most of the time, these bullets miss the Earth. Because, of course, there's so much empty space out there, the Earth is so tiny that they miss the Earth. But a few years ago, we dodged a bullet. And periodically, we dodged a bullet much more frequently than once every 100 years. Once every several decades, apparently, we have near misses. So far, they've missed. But they do happen. So these coronal mass discharges are not simply abstract, once-in-a-century event. They happen all the time. But they miss the Earth. One day, we may not be so lucky. What are your thoughts?
Well, as I say, we definitely need to protect our electrical grid and our computer systems from these events, because sooner or later one of them is going to hit the Earth. I mean, you're right, the Earth is small compared to the sun, but it's kind of like Russian roulette. And sooner or later we are going to get that bullet, and we need to protect ourselves.
And physicists from the National Academy of Sciences did a study, $2 trillion in property damage if we have a direct hit like what we had back in 1859. And some scientists went to Congress and asked for, a few $1 million to begin studies on how to reinforce satellites, how to create insulation, how to create ways of backup systems so that power stations are not wiped out. And basically, Congress just laughed at us. They thought it was science fiction, basically. But as you point out, it will happen, right? At some point in the future, you wait long enough, one of these bullets could hit the Earth, right?
That's right. I remember reading about a Republican congressman who actually took this problem seriously. I think he was from Maryland, but unfortunately he's no longer in Congress. So there were a few people in Congress that actually did take this matter seriously, but it would make a lot of sense to spend a few $1 million to protect ourselves from trillions of dollars of damage. Absolutely.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, our special guest is Dr. Ken Croswell of Berkeley, author of Alchemy of the Heavens. And today we're talking about the sun, stars. We're talking about something that seems so familiar. We see the sun every day, but it's life-giving. Everything on the earth depends upon the sun, but the sun itself has a life history. In fact, some physicists believe that the sun is a middle-aged star about halfway through its life cycle, with perhaps another 5 billion years left. We don't know the exact number, but eventually it will die. It will become a white dwarf star, and after that, perhaps even a black dwarf. But now let's talk about big stars, really, really big stars, stars that can explode. And after the explosion, you get a carcass. You get basically a corpse of a star called a neutron star. Now, how big is a neutron star? Believe it or not, neutron stars are about the size of Manhattan, 20 miles across. Incredible. So Ken, the astronomical community, didn't it take many decades for them to get their head around the fact that the theory seems to predict that the corpse of a black hole, a corpse of a supernova, after it blows up, is a neutron star that is so dense that it has the mass of a star, but its size is only about 20 miles across. What are your thoughts?
Well, I actually have a chapter about neutron stars in my book, The Lives of Stars. And yes, they were proposed to be the products of supernova explosions by scientists in the 1930s. But, it's not easy to find something that's maybe 12 or 13 miles across and does not really radiate much energy. It was only in the 1960s, late 60s, that we discovered pulsars, which are rapidly rotating neutron stars and emit radiation in a beam. And every time that beam sweeps past Earth, we see a blip or a pulse of radiation. And so very soon after that discovery, scientists recognized that these were the predicted neutron stars, predicted back in the 1930s. So, yes, we think that in most cases, when red supergiants explode, that they leave behind neutron stars. That's the collapsed core of the star. It's much lighter than the star itself. A typical red supergiant might be 8 or 10 or 20 solar masses, okay? So that much more massive than the sun, but a typical neutron star is only maybe 1.4 or 1.5, at most 2 or 2.1 solar masses. So the vast majority of the mass of the red supergiant is shot out into space when the star explodes. And, of course, that material contains heavy elements that are very important for life. And so those heavy elements that the star is manufactured during its life, and also some that were made during the supernova explosion, well, we are made of those elements today. So things like oxygen, magnesium, silicon, iron, of course. So very important elements all. So many of them came from supernova explosions.
Okay, so if a neutron star spins, rotates very rapidly, shoots out radiation like a spinning top, it becomes a pulsar. However, what happens when the neutron star is so massive that gravity takes over, crushes the neutrons into each other? At that point, there's nothing left to prevent a total collapse, right? So at that point, does it become a black hole?
Yes, indeed. In a neutron star, the repulsion between the neutrons actually holds up the star and prevents it from collapsing into a black hole. But if you add enough material, then it will eventually collapse and form a black hole. A black hole is an object that has so much gravity that nothing, not even light, the fastest thing in the universe, can escape. The best-known black hole is the one that was first discovered in constellation Cygnus, called Cygnus X1. That was discovered in 1971. The black hole orbits around a big blue star, and we observed that the blue star was going around something that we could not see. But we knew from its motion that the unseen object was quite massive. And today we estimate that the mass of that black hole in the Cygnus X1 system is about 15 times the mass of the sun. So that star began its life as a very bright and massive star, and it's ended up as a black hole.
Now, these are stellar black holes, that is, the remnants of giant stars that have collapsed under gravity. But we also have black holes at the center of galaxies that could be millions of times more massive than our sun. So were you astonished when just last year, photographs were published of a picture, the first picture of the event horizon of a black hole in the galaxy M87. Wasn't that a thrilling event?
It was, yes, and it was actually expected because astronomers had been working on imaging both the big black hole at the center of M87 and also the big black hole at the center of our galaxy. We still don't have an image of the one at the center of our galaxy, but I suspect that may come out in the next year or two. The one at the center of our galaxy is called Sagittarius A star. It's 4 million times as massive as the sun. It's the biggest black hole in our galaxy. However, the black hole in M87, which is 54 million light years away, is a lot bigger than our black hole. The one in M87 is something like 6 billion with a B solar masses.
Okay, well, unfortunately, we have run out of time.